Hello friends, myself R.D. Mahajan presenting my video on MCQs on inverse Laplace transform part 2. First example, inverse Laplace of f bar of s minus a is equals to find the correct option, we know that inverse Laplace of f bar of s is equals to f of t, say inverse Laplace of f bar of s minus a. How we know that that first shifting theorem is applicable here? Here that s is replaced by s minus a or s plus a. Then it is a problem of shifting theorem. Here it is replaced s by s minus a, and therefore by that shifting theorem we have e raised to at, as we have here minus 8, and therefore it is e raised to at into that f of t. Therefore, inverse Laplace of f bar of s minus a is equal to e raised to at into f of t as the answer. That is, option A is the correct option. Second example, inverse Laplace of 1 upon s minus a whole raised to n is equals to. And to find that correct option, we know that inverse Laplace of 1 by s raised to n, if it is not positive integer, its inverse Laplace is standard result t raised to n minus 1 upon gamma n as f of t, say. It is the inverse Laplace of that function. We call it as f of t. And then by shifting theorem, as s is replaced by s minus a, inverse Laplace of 1 upon s minus a whole raised to n is equals to, here s is replaced by s minus a, therefore it is a problem of shifting theorem, and as per that shifting theorem its inverse Laplace is e raised to at into f of t. Substituting the value of f of t as this one, and therefore we get that answer as e raised to at t raised to n minus 1 whole divided by gamma n as the answer, and it is option C out of that 4. Example number 3rd, if n is positive integer, then inverse Laplace of 1 upon s minus a whole raised to n is equals to, and to find the answer we know that inverse Laplace of 1 by s raised to n, if it is positive integer, it is equals to t raised to n minus 1 upon n minus 1 factorial. It is n minus 1 factorial, and we call this as f of t, say. Then by shifting theorem, why shifting theorem? Because s is replaced by here s minus a, and therefore by that shifting theorem inverse Laplace of 1 upon s minus a whole raised to n is equals to s replaced by s minus a, therefore it is e raised to at into that f of t. Substituting the value of f of t as this one, we get it is e raised to at t raised to n minus 1 upon n minus 1 factorial as the answer. Option A as the correct option. Example number 4, inverse Laplace of 1 upon s minus 2 whole cube, bracket cube, is equals to. And to find the correct option, we know that here the power is 3, a positive integer, and therefore whenever it is positive integer, inverse Laplace of 1 by s raised to n is t raised to n minus 1 upon n minus 1 factorial, and therefore inverse Laplace of 1 by s cube, as substituting value of n as 3 here, we get 3 minus 1 as 2 divided by 3 minus 1 factorial, that is 2 factorial, and we call this as f of t(c). Then by shifting theorem, inverse Laplace of 1 upon s minus 2, s is replaced by here s minus 2 whole raised to 3 is equals to, it is e raised to 80 into f of t, a is here 2, and therefore it is e raised to 2t into f of t. Substituting the value of f of t as this one, we get it is e raised to 2t t square divided by 2 factorial as the answer. Option B as the correct option. Fifth example, inverse Laplace of 1 upon s plus 1 whole raised to 1 by 2 is equals to, here the power is 1 by 2, and as it is not positive integer, we know that inverse Laplace of 1 by s raised to n, when it is not positive integer, it is t raised to n minus 1 divided by gamma n, and therefore applying this result we get inverse Laplace of 1 by s raised to 1 by 2 as t raised to 1 by 2 minus 1 divided by gamma of 1 by 2. It is half minus 1, we get minus 1 by 2 upon gamma 1 by 2. We can keep this gamma 1 by 2 as it is, or we can substitute the value of gamma 1 by 2 as root pi. In that option, that gamma term is there, therefore we keep this as it is. It is f of t say. Then by shifting theorem, inverse Laplace of 1 upon s plus 1, s is replaced by here s plus 1 raised to 1 by 2. As s is replaced by s plus 1, it is e raised to minus 80, a is here 1, and therefore minus t, minus 1 times t into f of t say. Substituting value of f of t as this one, and therefore we get that as e raised to minus t, t raised to minus 1 by 2 divided by gamma 1 by 2 as the answer. A is the correct option. Example number 6, inverse Laplace of 1 divided by s minus 1 whole square plus 4, 4 means 2 square, and that is equals to. And to find the answer or the correct option, we know that here s is replaced by s minus 1, therefore removing that 1 we get inverse Laplace of 1 by s square plus 4, 4 means 2 square. By standard result, it is 1 by a is here 2, sine of 80, sine of 2t, and we call this as f of t c. By shifting theorem, inverse Laplace of s replaced by s minus 1, therefore it is e raised to at, a is 1, therefore it is e raised to t into f of t, and that is equals to e raised to t by 2 sine of 2t. As option B is the correct option. Example number 7, inverse Laplace of s minus 2 whole divided by s minus 2 whole square bracket square plus 9. 9 means 3 square. And as here s is replaced by s minus 2 everywhere, it is a problem of shifting theorem. We know that inverse Laplace of cancelling that 2, we get the term s divided by s square plus 9. 9 means 3 square, and that is equals to, as per standard result, it is cos of 80 cos of 3t. We call this as f of t, say, and therefore by shifting theorem, inverse Laplace of s replaced by s minus 2 means s minus 2 divided by s minus 2 whole square plus 3 square, and that is equals to here s replaced by s minus a, therefore it is e raised to 80 means e raised to 2t into f of t. Substituting value of f of t here, we get that result as e raised to 2t into cos of 3t. As option C is the correct option. Example number 8, inverse Laplace of 1 divided by s minus 4 bracket square plus minus 16. Here s replaced by s minus 4 means it is a problem of shifting theorem. Cancelling that 4, we get inverse Laplace of 1 upon s square minus 16. 16 means 4 square. As per standard result, its inverse Laplace is 1 by a 1 by 4 sine hyperbolic 80 4t. We call it as f of t. Say, by shifting theorem, inverse Laplace of 1 divided by s minus 4 bracket square minus 4 square. As per that shifting theorem, it is e raised to, for minus we have plus 80, therefore e raised to 4t into f of t. Substituting value of f of t, we get it is e raised to 4t divided by 4 into sine h 4t. Option D is the correct option. Example number 9, inverse Laplace of s plus 7 divided by s plus 7 whole square minus 9. 9 means 3 square. As s is replaced by s plus 7 everywhere, it is a problem of shifting theorem. We know that inverse Laplace of, cancelling that 7th, we get s divided by s square minus 3 square. A standard result from inverse Laplace transform, it is cos h 80 is here 3, therefore cos h 3t, and we call this as f of t. Same. By shifting theorem, inverse Laplace s plus 7, s replaced by s plus 7 divided by s plus 7 whole square minus 3 square. It is e raised to 80 into f of t. Here it is plus, therefore e raised to minus 80 minus 70 into f of t. Substituting value of f of t here, we get it is e raised to minus 70 into cos hyperbolic 3t as the answer. Option B is the correct option. Out of that, a last example, example number 10, inverse Laplace of 1 divided by square root of 2s plus 3. Again here s replaced by s plus a type of term. That given inverse Laplace of 1 upon root of 2s plus 3, we have to rewrite it in the form of either s plus a or s minus a. Means coefficient we have to make as 1, and therefore to have that coefficient as 1, we take this 2 as common, and therefore when we take it outside the square root, it is 1 by root 2 inverse Laplace of remaining terms are by taking 2 common from this, it is s plus 3 by 2, and square root means raised to 1 by 2. I have written it in new form. And then to find the inverse means to find the inverse of this, we know that here the power is not a positive integer, and therefore we know that inverse Laplace of 1 by s to n as t raised to n minus 1 divided by gamma n, and therefore inverse Laplace of 1 by ss to 1 by 2, it is equals to t raised to 1 by 2 minus 1 divided by gamma 1 by 2, it is t raised to 1 by 2 minus 1, we get minus 1 by 2, and this standard value of gamma 1 by 2 is root pi. We call this as f of t, say, and therefore inverse Laplace, therefore that 1 by root 2 into inverse Laplace of 1 divided by s plus 3 by 2, that raised to 1 by 2, as s replaced by s plus a by shifting theorem, we get this is equals to 1 by root 2 we keep as it is. When s replaced by s plus a, it is e raised to minus 80 minus 3 by 2 times t into f of t, and therefore it is 1 by root 2 as it is, e raised to minus 3 by 2 times t, and f of t is t raised to minus 1 by 2 divided by root pi. Option C is the correct option. In my next video, I will discuss some more examples from this MCQs on inverse Laplace transform. If you are watching my videos, please like and share it, as well as subscribe to my channel to get new updates. Thank you. Thank you very much.